2 using patterns. Objective of this lesson to learn and solve problems using patterns. Let's take a look at this honeycomb. Patterns are all around us, even in a bee's honeycomb. Think about your day. What events follow a pattern? Do you always have the same class after lunch? Does your school day always end at the same time? Those are good examples of patterns. You also have patterns at home. What time you sleep at night. Let's say if you are watching a specific TV show, what time it comes up every week. Okay, those are examples of patterns. Or what time do you go to church every Sunday or every Saturday? So in this lesson, we will use patterns to solve problems, and that's what we want to find out. We want to learn. Okay, let's take a look at example number 1. Draw the next 3 figures in the pattern. And if you notice, okay, in the first figure, the top left corner is shaded, and then the figures that follow the shaded corner moves counterclockwise. So it moves something like this. From that side, moves this way. That's how you get that green. Then it moves to the right. That's why you get this. And moves on top. That's why you get this pattern right here. And so on and so forth. So the next 3 figures, okay, if you follow the same pattern, will look like this. Okay, the yellow shaded area will go down here, okay, which is this one, and then it'll go to the right, which is this one, and it'll go on top. Okay, that's an example of a pattern. Okay, in the next example, draw the next 3 figures in the pattern and take a look at the orange triangle. And if you look at that one, the triangle moves clockwise. Okay, basically, if this is an equilateral triangle, it moves clockwise. Okay, going down means clockwise this way. Okay, so from there, triangle moves clockwise. The next 3 figures are drawn below, and if you continue that pattern of the triangle moving clockwise, 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 this orange triangle will be in that spot right there. Okay, and this orange triangle will move up and move down, okay, as follows. So those are 2 examples of patterns. Let's take a look at patterns that involve numbers. Find the next 3 numbers in the pattern: 6, 11, 16, 21. And if you notice, the question is, how do we get each succeeding number? And if you notice, when you go from 6 to 11, you add 5, 11 to 16, you add 5, and 16 to 21, you add 5. So this is the pattern now, adding 5 to get the succeeding number. So what we do now is simply add 21 plus 5 will give us 26, and then we add 5 to 26, which will give us 31, and we add 5 to 31, which will give us 36. So the next 3 numbers in that pattern would be 26, 31, and 36. Want to find the next 3 pattern, okay, in 2, 4, 6, 8, and 16. How do you get each succeeding number? By studying the pattern. If you notice, to be able to get to 4, you multiply by 2. To be able to get to 8, you multiply by 2. To be able to get to 16, you multiply by 2. That's our pattern, by multiplying each number by 2. So multiply it by 2, you get now 16 times 2 will be 32, and get 32, multiply that by 2 will give you 64, and 64 multiplied by 2 will give you 128. So the next 3 numbers in that pattern are 32, 64, and 128. Okay, let's take a look at this example. Making a table helps organize this information. So this example emphasizes table making. Okay, because if you create a table, it will better organize your thoughts, and at the same time better get you to the answer a lot faster. Okay, so a staircase that is 4 cubes high is shown at the right. Notice that 10 cubes are needed to build the staircase. So this is your staircase, and you have 10 cubes needed to build that staircase. Copy the chart below, then use centimeter cubes to find the number of cubes needed to build each staircase. So let's do this. Let's say you don't have centimeter cubes. Let's just imagine. Okay? So if you have the height of the staircase is 1 cube, right there, 1 cube high, the number of cubes needed to make it 1 cube high will obviously be equal to 1. If the staircase is 2 cubes high, the number of cubes needed to make that staircase would be 3. Okay? And if the staircase were 3 cubes high, the number of cubes needed to build that staircase would be 6. And 4 cubes would be equal to 10, just like what was said at the beginning of this example. Okay? So the question is, how many cubes will be needed to create a staircase that is 5 cubes high, 6 cubes high, and 7 cubes high? If you notice, okay, in this example, to be able to get to 3, you added 2 cubes. To be able to get to 6, you added 3 cubes. To be able to get to 10, you added 4 cubes. So the pattern is now brewing: plus 2, plus 3, plus 4. Okay? And that's the answer for example number 2. Describe the pattern that you see in the number of cubes needed to build each staircase. You add 1 every time you create a new staircase. Okay? So in this case now, you add 5. If I add 5 to 10, that would be 15. And if I add 6 to 15, because that's the pattern, 2, 3, 4, 5, 6, that would be 21. Okay? And if I add 7 to 21, that would be 28. So if my staircase is 7 cubes high, that would be 28. Number of cubes needed to build each staircase are increasing by 2, 3, 4, 5, and so on. That's the answer for number 2. Use the pattern to find the number of cubes needed to build a staircase that are 9 cubes and 10 cubes without using centimeter cubes by just following this chart right here. Okay, to be able to get to 9 cubes, that would be 45 cubes and 55 cubes. Why is that? Because now, to be able to, if let's say we extend this, okay, and we go to 8, the staircase would be 8 cubes high. We add 8, and that would be 36 cubes. Okay, extend it some more. If we add now, let's take, put it green. Okay, 9 cubes high. We add 9 now, and that would be 45 cubes. Okay, and on the 10th staircase, put it right here. Okay, we add 10, brings us to 55 cubes. And that's how we got 45, and that's how we got 55 cubes. Okay? Good, example number 5. Okay, and let's figure out how this works. Did we do example number 4? Let me check if we did example number 4. Check if we did example number 4. Yes, we did. So we're moving on to example number 5. Okay. Geometry. The marching band wants to make a triangular formation on the football field. Triangular formations with 2, 3, 4, and 5 students at the bookcase at the base look as follows. Okay. So if you have a marching band with only a base of 2, there will only be 3 students at that one. Okay, when you have a marching band with 3 students at the base, you have a total of 6 students all in all. 4 students at the base, 10. 5 students at the base would give you 15 students. Okay, so how many students are needed to make a triangular formation with 8 students at the base? And following what we learned from lesson 1, the 4-step plan, let's find out what we know already or what we need to know. You know that the number of students needed to make a formation with 2, 3, 4, and 5 students at the base. You need to find the number of students to make a formation with 8 students at the base. So this is what we need to find out. Always in a word problem, okay, you try to find what is being asked of you. Okay, then we plan to solve our problem. How do we solve the problem? Make a table to organize the information. then study the table to find the pattern. And that just as what we did with the cubes, we create a table for this. And this is how the table would look like. If you have a base of 2 students, 3, you'll have a total number of students to make that triangle would be 3. Base of 3, 6, 4, 10, 5, 15. Okay, that's what we have there. What we want to find out now, what if you have a base of 6, a base of 7, and a base of 8? How many students would be needed to create the triangle formation? Okay, so you add 3, add 4, you add 5 every single time. And if you now have 6 students, okay, you'll the extra students needed to increase by 1 each time. Use the pattern to complete the chart, so you increase it by 1. Okay, you now have 15 plus 6 will give you 21 students for a base of 6 students. You have 28 students for a base of 7 students. Okay, and 36 students for a base of 8 students. Okay, so the answer would be 36 would be needed to make a triangular formation with 8 students at the base. And checking our answer, if we draw a triangular formation with 8 dots at the base, okay, check to see if there are 36 dots in the formation. Basically saying, if you want to check your answer, just simply create 8 dots, 1, 2, 3, 4, 5, 6, 7, 8, and then start creating that until you end up with a triangle, and that should end up with 36 students. Okay? Lesson's done. Google Forms, type a summary of what you've learned by responding to the objectives of the lesson, and then type a question you might want to ask in class about this lesson. Thank you.